Well, welcome back, everybody. We are going to continue on with differential equations today. This is what I call section 6C in your book, Differential Equations with Growth and Decay Models. So in your calendar, I said differential equations, word problems. These differential equations are actually going to be much easier than the ones you had for homework from section 6B. But these types of situations do arise, especially on the AP exam for your multiple choice section. So we want to look at these really, they're really more pre-calc type problems, to be honest. So we are going to go through the theory today, which is the calculus portion. Okay, so in many applications, the rate of change of a variable y is proportional to the value of y. If y is a function of time t, the proportion can be written as this. All right, so I'd like for you to go ahead and write what I have down here, as well as the different labels I have here. So the rate of change of y would be dy dt, right? The change of y with respect to time. Would be equal, and proportional to y would be k times y, or some kind of constant proportionality. Typically textbooks use k. Okay, so what I would like to do is solve for y, actually. And we're going to do this using our tools from yesterday. Okay, so if I want to solve this differential equation for y, the first thing when solving for differential equations is to do what? Separate, right? So how about I divide both sides by y? I can leave the k on the right side. You can go either way with the k, because that's just a constant, but I'm going to leave the k on the right side. So let's divide both sides by y and multiply both sides by dt. So I would have dy divided by y is equal to k dt, right? All right, now I've separated, so the second step would be to integrate. Okay, can you figure out the antiderivative here? So what's the antiderivative of essentially 1 over y? That would be ln of the absolute value of y, right? In this case, it says assume y is positive, so just ln of y is fine. And what would the antiderivative of a constant be? Well, that would just be k times x typically, but in this case, our variable is t. Right? If I took the derivative of this with respect to t, I would get back to k. All right. So now we want to solve for y. So I want to get rid of this ln. So I would exponentiate both sides. So I would have y equals e to the k t plus c. Okay, now let's come to the side here, just a bit of exponent review. If I have e to the third times e to the fifth, in total I have how many e's? I'd have e to the eighth, right? E to the 3 plus 5. So I have a similar situation here, just going the other way around. I can actually split this up into e to the k t times e to the c. Okay, why did I do that? Well, this part here, e to the c, is just some other constant, isn't it? E is a constant, c is a constant, so a constant raised to a constant, that's just some other constant, and textbooks typically call that constant a. All right, so what I'm going to have is y equals e to the kt times a, or how we typically see it, y equals a times e to the kt. Okay, so why did we do all that? Well, kind of did it as a shortcut for you, because now whenever you see a word problem that says the rate of change of something is proportional to that, to itself, we can just skip straight down to this equation here. This should look familiar from pre-calc. Maybe it would look more familiar if I wrote it as the amount equals principal times E to the rate times time, PERT, right? Same thing, we're just using different letters. Okay, we're using Y instead of A instead of P, and K instead of R. Okay, but same idea. Alrighty. Okay, what I would like for you to do now is go ahead and pause the screen, make this table in your notes, and then we're gonna rewrite them in calculus symbols on the right side. Okay, so for the first one, it says the rate of change of y is proportional to x. Well, that's the one we just worked with. That's the one you'll see the most. So the rate of change of y, that would be dy dx, would be equals proportional, so I need a constant proportionality, to x. Okay. The second one, the rate of change of y is inversely proportional to x. So in other words, as y increases, x decreases, and vice versa. So the rate of change of y is inversely proportional. Do you remember how to do that? So as the rate of change of y increases, x decreases. Okay, so x needs to be in the denominator. All right, the last one, the rate of change of y varies jointly as x and the quantity n minus y. Well, jointly really just means the product. Okay, so the rate of change of y, dy dx, varies jointly as x and n minus y. So I need my constant proportionality and then the product of x times the quantity n minus y. Okay, and those may come in handy for some of your homework problems there. Okay, let's do a couple examples. First example here, it says the rate of change of y is proportional to y. And then you want to write this information down when x equals 0, y equals 2. And when x equals 3, y equals 6. If you'd like to write those as ordered pairs, that's fine. Then what is the value of y when x is equal to 9? Okay. First thing I notice is the rate of change of y is proportional to y. Well, because of this, I know that I can skip. I did the calculus for that initial problem, and I got to that, right? In this case, it looks like instead of using t, we're using what other variable? K, right? Okay, so because of this first statement here, I know I can start with that. So what I need to do, though, is find values for my two constants. And what are my two constants? A and K, right? E, I already know the value of, and then x and y are variables. All right, so I'm going to start with y is equal to a times e to the kt. And let's go ahead and plug in this first piece of information here. So when x is 0, y is 2. So 2 equals a e to the k times 0, right? So 0 here. Let me change that. This should be an x, right? Looks like a t. All right. So e to the 0 is what? Is 1. So I get that a is 2. So that's good. I now have one of my constants. right? Okay, so now let's plug that in for a. So y equals 2e to the k times x. I still need to find what other constant? Still need to find k, right? So how can we do that? Well, let's use the second ordered pair. So 6 is equal to 2 times e to the k times 3. All right, I'd like to solve for k, so what's the first thing you want to do? First thing we need to do is get rid of that 2 on the right side. Okay, so divide both sides by 2, I get 3 equals e to the k times 3 is the same as 3 times k, right? All right, now how do I get rid of the e? ln of both sides. And now what? Divide both sides by 3. Okay. These are calculator active, so let's go ahead and put this in our calculator. And what I want you to do is store this, and I'd recommend storing it as the letter K. So let's go to our calculators. So ln of 3 divided by 3, hit enter there. All right, so you have two options. You either need to write down that whole decimal, and I do mean the whole decimal. Do not round these till the end. These are especially important that you don't round to the end because we're dealing with exponential equations, which can grow very, very quickly. All right, so you can write that whole thing down. Or if you want to just store it in your calculator, if you'll hit the store button, it's right above the on button. And then you can store it as whatever letter you'd like. I'd recommend just using k since that's what we had in our equation. Then I can just pull a k in whenever I need it. Okay. So if you don't want to worry about storing things, then you need to go ahead and write down the full decimal as many places as your calculator gives you. If you're using like an Inspire and it's only giving you 3 or 4 decimal places, we need to get your settings changed on that because you need more than that. Okay, so I now have my 2 constants, so I can now go and actually answer the question. So the question is, what is the value of y when x is 9? So now I can write my full equation. So y equals 2e to the ln of 3 divided by 3, or k if you stored it as k. Or if you wrote down the whole decimal, you should have gotten 0.366 ... something. Okay, so now I just need to go and type this into my calculator. So y equals 2 times e to that k value times 9. Okay, so 2 times e to that k value, so I'm just going to do alpha k times 9. And I'm getting a nice round 54 here. And if you think about your laws of logs, you'll probably see why that was the case. If you typed in that decimal, you may have gotten like 53.99999. Remember, we need accurate to 3 decimal places, so you'll be fine there. Okay, and our answer is 54. So, that is our final answer there. Okay, let's do one last example. Let's go ahead and do the first one from your homework together, please. By the way, if we go back here, numbers 21 through 24 are all like this. So numbers 21 through 24 are all like this example. Okay. All right, let's do the first one from your homework, and then we'll call it good. This is number 11 from your homework. We have dq dt is equal to k over t squared, correct? All right, so when we're solving this differential equation, so this is going to be similar to what you did yesterday, you just don't have an initial condition, so you're going to have, you won't need to find your plus c, you'll just have a plus c in your answer. So when solving differential equations, first thing you want to do is what? First thing we want to do is separate, right? So I have q's on the left, t's on the right. Looks like I don't have any q's other than just dq, so I can keep that on the left side. And then the only t I need to move is the dt, right? So I separated. Now what? Now we integrate. Okay. So this is, you can think of this as the integral of 1 dq. And I'd recommend rewriting this. A couple things I would do. What's the first thing I would do? Probably pull out that k, right? To the front there. And what about this 1 over t squared? You should rewrite it as t to the negative 2. Okay, so now let's go ahead and find the antiderivatives. Antiderivative of 1 with respect to q this time would be q, right? Like the antiderivative of 1 with respect to x would be 1x. Okay. Here, the k comes along for the ride. What are you going to do here? Well, you're going to add 1 to the exponent, so that'd be negative 1. Then you want to divide by negative 1 also, correct? Plus c. Okay, and that's our answer. We don't have an initial condition to plug in, so as promised, these are easier than yesterday's. I would just rewrite this, make it pretty. Let's put that negative 1 in front, k, and then let's rewrite that t to the negative 1 as t to the positive 1 in the denominator, plus c. And that's it, guys. That is it for differential equations. So your homework should not take very long at all. If you're interested, I do have some worked out problems from yesterday's homework back from last year. So if you want to go to our website and pull up these notes, the PDF, then the first 3 slides are, looks like numbers 4 and 6 on APSI and 27 on page 431 if you're interested in seeing those solutions. All right, I will see you guys next time.